from Department of Biology. This is my PI. Right. She's going to be talking about Legionella in potting soil. One little quick thing. This is a project she started last year, but along with another student. But anyhow, we put the samples in the incubator, some possible positives right before spring break. We're going to come after spring break and see them, but you guys don't have to know spring break. So anyhow, this is kind of like a continuation of that project, and hopefully she's going to be doing some graduate work with Legionella in another capacity, but we're kind of just finishing up this project. So I believe this is her first presentation, so please be kind. Good luck.
Okay, well, my name is Rayne, and like he said, we started this last year, but we didn't get to do a really good continuation of what we had already seen. For Legionella, most people have either heard of it or haven't, but if you've never heard about it, it's widely known and in the news quite often. One of the actual home hits is like in Oxford, the hotel zone in Oxford. They had a case happen, and it costed them $5 million in lawsuits. So it's actually a really prevalent disease, and it is in our news, and most people are unaware of exactly what it is and what it does to everyone. So looking at rates of increasing cases of the Legionnaire's disease or the detection of Legionella, from 2000 to 2017, it has increased by almost 500%, which is a large number. And then here in Alabama itself, we now see 60 to 80 cases of Legionnaire's disease every single year. And that number is constantly growing because of how it's spreading. And mostly though, healthy people, you're still at risk at getting it, but we mostly see it in elderly or immunocompromised, but everybody is at risk. If they contract the disease, they will either end up with Legionnaire's disease or Pontiac fever. Pontiac fever is a mild case, kind of like flu-like symptoms, but Legionnaire's disease is much more fatal. They will suffer from respiratory failure, multiple organ failure, and if they do survive, then they end up with long-term damage such as tissue damage, neurological damage, and they can suffer different things and have asthma for the rest of their life because it scars their lung tissues. So how is it transmitted? We know it's transmitted through aerosolized water such as showers, spas, things like that. What I look at is how is it transmitted through potting soil. For people who work with the potting soil, like hobbies for elderly people who love to garden, you get a bag of potting soil, you put it out in your garden, you breathe in that now aerosolized Legionella because it is inside those molecules and it lives within the amoeba in the soil. That's what I look at. So my question is, can I detect Legionella in the potting soil in local areas? Because I'm studying Alabama. We're planning on getting multiple samples of indoor potting soil that has been kept inside, outdoor potting soil that has been sitting out in the sunlight to incubate and have created its moisture. And I'm planning on getting all kinds of different samples from all over the area and counties. So that way it gives a better variety of where is that Legionella at. We just don't have an access point or a direct pinpoint of where Legionella comes from when it pertains to soil. It's very, very hard to detect. So the way that I am going to go about finding it is doing culture dependent and then culture independent. I'm planning on starting the culture independent in the spring, which will deal with real-time PCR, because we haven't grown a whole lot yet, because potting soil is just now becoming available to us because it is a spring thing. So the most important things about this bacterium is that it is a BSL-2 pathogen, which means we have to take precautions when working with it because it is a very aerosolized pathogen. It's very, very significant and basically dangerous to deal with. So thanks to Dr. Hemsley, we were able to get a biosafety cabinet, which you can see in this picture, which I work with. It is very secure and safe, and I think the biology department, otherwise I wouldn't be able to get to work with it in the manner that I do with the proper protection. And JSU's lab is one of the few universities that has a CDC elite certification giving us the permission to work with these pathogens. So what do? We collect all the samples from different potting soils, again from all over the area. And once we do that, we have to separate the bacterium from the soil. So we're gonna suspend it in a sterile water solution, And once it's been in that solution, we're going to mix it. The reason why that picture is blurry is because it's on the vortex getting shaken for the proper amount of time in order to separate the bacteria from the soil. And we know that that soil, everything is in soil, it's a decomposing, it has all kinds of different organisms, a bunch of bacteria, so we put the soil through an acid treatment. Legionella has the ability to withstand some acid, most acid treatments, and it still can grow and prosper. So by using the acid treatment here, it allows for to kill off any other competing organisms that are competing with the Legionella for growth, allowing us to see the Legionella species growing on the plates. The plates are going to be spread on, the sample is going to be spread out on plates, and those plates are going to be incubated for 5 to 7 days. And during that incubation period, they will be checked periodically for colony growth. And as they're spread, you have to make sure that the whole plate is very, very inoculated. Otherwise, because Legionella is not a very sharing bacteria, it is very selfish. So that's also why we incubate and do the acid treatment to make sure that that Legionella has the chance to grow on its own. And again, they're going to be observed under microscope periodically, 3 days, 5 days, and 7 days. That's why we give it a week to grow. After that, if it is positive, based on the detection of the colony, looking at the colony's characteristics, we will put it through, of course, real-time PCR to tell exactly what species it is. And this test right here is a agglutination. And by looking at it, this first bubble right here with the check mark tells me if it's serogroup 1. The next one with the X and it's labeled number 5 tells me if it's serogroup 2 through 14. And then the last one tells me if it is a Legionella species or not. With that being said, you can see clumping, probably not as well as I'd like you to, but you can see the clumping in that first one telling me that it is Legionella serogroup 1. So we have processed 5 samples again, like Richard said in the beginning. We processed 5 samples last semester, and then we all know what happened after that, so didn't get to have a continuation, which was very disappointing because I really, really enjoy this. I enjoy studying things that most people are unfamiliar with because I want to be able to educate those on things that are unfamiliar or, in words, feared. But giving public awareness, I believe, would be the best way to fix those issues. So, like I said, potting soil is just now becoming available, so I'm planning on doing a very wide range of samples as best as I can with the help from Richard and the biology department here. And right now I have 3 samples incubating that I've already processed, and we will see how they go in a couple days when they're finished the whole incubation period. But I'd like to thank Richard because he's the one that helped me get started with it, and of course the biology department because they allow me to work here. And HGS Engineering is actually an analytical company. HGS, I work with them currently with Legionella. They work with it in water samples. And they have donated materials such as plates and things that are out of date or something that I can use myself and use them on this project. They've donated to us too. So I appreciate all of them. And so, does anybody have any questions for me? Yes, ma'am.
Should we be wearing masks?
See, that's something that we don't exactly know yet. That's what I'm researching. So water contamination, we know it gets in the water and it will spread aerosols. Now with soil, that's why I'm studying it. Does it actually get, like the soil, you know, of course it blows up in your face, that's why we start sneezing. But we don't know exactly how much is transferred when it's like dusted out or something like that, or when you're digging, or that's what I'm working on. I'm working towards being able to calculate CFUs per basically bag of potting soil, so to speak, and knowing how it's being transmitted, how people are contracting the disease, and how much of it is being absorbed into a human. So the infection number we know is very low due to the literature. So right now, we don't know exactly what that number is. To me, I feel like it would be a 1 because of how serious the disease is and how serious the pathogen is, but that is just my personal thought of the disease itself. The literature does say it's very, very low though. That's something that I'm trying to research and gain knowledge about. Okay.
So what happens if you get results in the future that
pretty concise that Legionella is found in the soil. Would you try and go public about that and try to get in touch with the companies?
That's what we actually were debating that yesterday. We've been talking about that topic. As of right now, I would just talk to it about with my advisor and what the School of Science would say to do, because in that sense, there are a bunch of legalities that probably would have to be, but it would need to be a known thing because it would be a community problem. It would be more than just one bag of soil. So like you saw, I had the news articles in New York, and there's some in Florida, there's some in UAB. It would become a national problem if it was distributed, because like whenever Bluebell had listeria in their ice cream, that was a national problem that was all recalled. So that would be the same instance with that soil if that were to happen.
Have you worked with the Public Health Environmental Safety Division at all, or talked to them about any of their background or potential findings, or how they check for this as well?
I have not personally talked to them, no, but I've done a ton of research. Like I've looked at all the CDC protocols and ISO's protocols and stuff like that. But personally, I have not actually had contact with them. I do use a ton of references from places like that, making sure that I'm matching their protocols versus what I'm looking for in testing. And that's what I have Richard for, to make sure I'm doing it all the right way and looking at the right things every time. So I'm very thankful he can guide me through it, and if he doesn't know, he goes and looks too. So that's the point. That's the best thing about research, is that we always look for it if we possibly can. I've not directly had contact with them.
I just have one more question. Has there been any cases at all so far reported about spotting soil and Legionnaires?
I'm sorry, I didn't hear you.
Have there been any cases reported as of yet about spotting soils and Legionnaires?
Has there been? One of the researches I did was the first case found in Alabama was found in 2000.
Oh, okay.
That was the most recent one that I've read enough information about to clarify. I know that they have had, they've had positives, but they can't pinpoint exactly where they came from. So that's another problem that we're running into, is this Legionella actually coming from the water, or is it coming from the potting soil? And we can't say yes or no yet until we have enough background to back that up.
The asbestos and the talcum powder.
Yes, ma'am. Yes, ma'am.
Yeah.
There's so many different things about Legionella and how it spreads and how it gets into piping and water sources that it makes it very difficult to know if it's actually spreading through that soil or just that water. And that's why whenever the hotels in Oxford had such a big problem, it costed them so much, because it took them a really long time to link it back to them because of how much processing it takes to figure it out. And like there's a lot of stuff that goes medically into diagnosing Legionnaire's disease, like chest x-rays, because it appears it's just an pneumonia, but they don't know exactly what's causing it. And so they have to do those cultures on the sputum or of the lungs with those chest x-rays to compare it to see if it's actually Legionnaire's disease or if it's just the straight up pneumonia. And then they have to go from there to figure out where did they contract it. And being science, we all know that bacteria spreads within just like me breathing in 5 seconds. So it's very hard to pinpoint, but that's what I'm hoping to gain knowledge about. Yes, ma'am.
How long is the incubation period?
For most of them, you have an incubation period of up to 7 days. The reason why is because colonies for Legionella, it's a very slow growing bacterium. So it'll form teeny tiny pinpoint colonies on a plate. And that's not enough information to subculture or to run real-time PCR on, because it's just so tiny. So that's why we check every 3 days, 5 days, and 7 days. It gives it enough time to grow and spread on the plate in which it is growing on, and it gives me enough time to look at the characteristics of it to make sure that I'm looking at Legionella and not something else like Pseudomonas or something like that may be contaminated on that plate. And then from there, I do subcultures on it, and that's how we look at incubation time, is how long is it best for me to be able to get enough of it to incubate it and subculture it for later and be able to run PCR. So 7 days has always seemed to be about a very good time frame, because if you go too long, then it denatures and the characteristics no longer look how it should, and it may not act the same, it may not come off of the plate the same way. And so normally I always do my soap cultures on day 7. Thank you.
Was that question for you?